Hi all, welcome to week 3's post-tutorial recap. After our 2-hour class, we have learned many new things this week. So I would like to focus here is the formation of line spectrum. We have done this in class thoroughly, but it's okay. Let's hear it again in my voice. Okay, so we have our Bohr's atomic model over here, a simple description, and I hope you recall that n equals to 1 is our ground state, and all the other higher energy levels we can classify it as excited states. Okay, so let's start describing the formation of line spectrum here. So what do we have here? So you must remember that energy of an electron in a hydrogen atom is quantized. Quantized means fixed energy. All right, it's fixed. So when the electron at its ground state, okay, absorbs energy, it is excited to higher energy level. As you can see over here, the electron is excited to higher energy level. And what happens at the excited state? The electron is unstable. So when it's unstable, what does it do? It falls back to the lower energy level. So during this fallback, which we said as during the transition of electron from the higher to lower energy level, it releases energy in the form of light, which we call photon. And this photon has got specific frequency and wavelength. We have discussed this in class. Due to this particular property only, we were able to detect it on a line spectrum. So these photons now produce the lines in the hydrogen spectrum. So for example, if let's say the question is asking you to describe the formation of line spectrum for an hydrogen atom, you should be able to reproduce this. Alright, and before I end the video, I'll just recap on the weakness of Bohr atomic model. We have actually seen 4 weaknesses of the Bohr atomic model. I'm just going to highlight one over here, the main one, which is why we are not continuing the use of Bohr's atomic model. Okay, and Bohr's postulates is that it is unable to explain the line spectrum of atoms or ions that has more than one electron. Alright, and what about the summary of the dual nature of electrons by de Broglie? So we have to remember that, and de Broglie said electrons have dual nature, whereby it can show wave behavior as well as a particle behavior. So if it's a wave behavior, energy can be calculated using E equals to h nu, and if it's a particle behavior, we can calculate it using E equals to mc squared, the Einstein equation. Finally, we also had a look at Heisenberg's uncertainty principle, whereby, I think I gave you the F1 analogy, I hope it helped. It is impossible to know the momentum and position of a particle with certainty. I'm sorry, I wrote the uncertainty, it's actually with certainty. Alright. Okay, so it is impossible to know the speed basically, because momentum is mass times velocity, and position of a particle with 100% certainty. That's what Heisenberg said. Okay, I hope that was a good recall after our 2-hour class. I'll see you in